I'm going to begin this presentation by telling you a story. I find it very interesting, and throughout the years it stayed true for some reason. So it begins with all the stories that we have with one king who wanted to marry his daughter, and of course we always get this pair of you get the daughter's hand along with half the kingdom. To address this challenge, we have a bunch of princes coming up and lining up for the quest, and let's say we have about 50 of them, plenty for a challenge. And the emperor says, okay, we have 3 challenges for you, and the fourth one just as a bonus. Quite easy for the fourth one. First challenge, I want you to build me a house. You have 1 week, build a house. Well, our Prince Charming says, pretty easy, sketches 4 walls, 2 windows, 1 door, and gets to work. Simple wood framework would be enough, places all the walls, finishes in 3 days, and the rest of 4 days just spends gazing at the sun. And just as the emperor comes back at the end of the week, he sees that there are only 20 princes remaining. And he says, thank you, this is going so well. For you, here's the next challenge. And I would like you to build me a basement for this house. But I want it to be twice the size of the house. Now, this is the part where Prince Charming starts to panic because, well, you have to think the basement before building the house. But okay, maybe if I dig a little bit deeper, and then maybe the earth will support the weight of the house. So, okay, let's do it like this. He starts working, traveling all the way through all the week. And just as he pulls the last bucket of dirt out of the basement, the king returns to see the progress. And he sees that only 5 princes remain that were able to do that task. And he says, thank you very much for your participation. And to get to the final contender, I will now tell you what is the last challenge. I would like you to build me an extra floor for the house. Well, this is the part where he gets a bit lucky and a bit afraid because, well, he built a flat roof, so that was easy. But then again, it was a wood framework, not really meant to support anything else. So he had to do some reinforcements on the inside, on the outside. He actually got to build the roof right on time. And just as the king returned, he saw that he was the only one that completed the task. And said, thank you, Prince Charming. I knew you were the chosen one. Look, for you, I'll just tell you the last challenge. It's very easy. You have to sleep 1 night in this house. Our story ends here because the next day the prince was picked up from the collapsed house. And if you're wondering why I told you a story with an emperor and the prince, try replacing emperor with product owner and house your project. And take a wild guess with the prince. The agenda for today is I would like to talk to you about how we actually faced the third challenge and how we what was the situation, how we actually got to a solution, and how we very neatly, I would say, implemented this, and of course, lessons learned. So what do we have? First of all, we had a project. It was the third sprint. It started from a proof of concept. And we had one service in a microservice architecture, one service that was really big, and the offender was the main class. Main class was just 1,000 lines of code, but about 600 of them were callbacks. So it was a place where we kind of went on every sprint, looked at it and said, no, okay, let's go back. It was working, it was fine, but it had no error handling, no documentation, and we simply could not figure out, for the love of God, where to make changes. Now, it so happens that in the first 2 sprints, we managed to dodge it. And okay, we kind of did fixes everywhere around it. And in the third sprint, without really realizing, all our features were for this class, and they had to be done in that class. And we were a bit stunned and said, okay, let's put it on one line. What do we have? Tests. Not really. We had about 8 tests, and they were not quite nice because callbacks means that you don't usually get to see when it finishes. So our integration tests, despite our best efforts, still had some timeout. Okay, wait for this to finish and wait for a number of seconds. Very brittle. Our unit tests were covering edge areas, not really relevant. We really had no idea where to put new features in this class or how to break it down. And since it wasn't emerging from proof of concept, it really didn't have a very clean architecture. Business complexity. So what the owner wanted us to do was okayish, as in he was aware that it was a proof of concept, it was innovation. He was willing to give us some slack. However, code complexity for just 600 lines was a pain. We couldn't break it down with normal refactoring systems. And for documentation, we had about 0 lines of anything, including code comments, markdowns, anything. It was just not there. I put this into a chart because I would like to show you the progress over the sprint. And documentability 0, a bit of tests, and complexity right there. Okay, so we said we're not going to work with callbacks. Let's pick another way. What do we want? Well, first of all, we want something that supports testing, because we were going to build something that would last in time. So the more complex it gets, the harder it is to change. So tests are going to prevent us from breaking it further down the line. Also, in our special case, we had no QA resource. So just development, it has to be automated testing, no other way around it. We wanted to be easy to update to new features, because this is one of the biggest issues I've seen in development. When you build it, it's nice, and as soon as you start adding features more and more and more, it starts making it becomes more brittle and more complex, and it just stops at some point. We wanted to reduce complexity. And most of all, because this was a sprint and we kind of promised we'll deliver some features, it should be done in 15 days. Said, okay, it's fine, we can just fix it. So our first 3 days, the searching went very well. We had no solutions or no patterns that we could go to and say, okay, let's do it like this. So on the third day, we said, okay, we have to do something. Let's pick one of them, one of the things that we found. And we went for Eric's Java and the observable design pattern. It looked very promising. You know, everything was asynchronous. It was being praised on the internet as the next level. Wow. And it was already available from one of our dependencies. Cool. Except it had a very steep learning curve, and that was a bit of a bummer because, well, we have 15 days, but yeah, we are smart guys. We can do it. We are okay. So the first 4 days we spent by learning Eric's Java from documentation and redoing the flow from callbacks to Eric's, basically, just a map that was basically converting all the callbacks into one long stream of data processing. Now, this didn't look quite well. You know, we picked the top tool, we played with it, we implemented it, and yet we got none of the benefits that were advertised. And we realized our mistake was that we are trying to learn it from documentation. Now, it is very good if you want to find out fine details or how things work, and you got documentation. But it's more like, for us, it was like going to a hardware store, and we had 200 types of screws and 100 types of wood and a couple of dozens of power tools, and we wanted a chair. And nobody on here told us how to build a chair. So how are we doing so far? Okay, we wrote this, and we were able to kind of document here and there some code comments, maybe a bit more flexible with Eric's, but none of anything else. So, okay, something was wrong. Something was very wrong. But at this point, we realized that we are in the middle of a sprint. So we had to take a decision. Either we revert, start from callbacks and kind of patch it around to make it work, or move on. We did a small discussion, and the conclusion was that we will burn the ships. We are not going back. I'll tick whatever it is behind door number 2. So we did what every sane team would do. We called up a meeting, and we titled the meeting, "We don't know Eric's yet." We tried to look through some resources on design patterns, couldn't quite find anything, but the $1 million phrase that we got from a YouTube video was that we were doing it all wrong, meaning that when you're doing Eric's, you are being reactive. You are reacting to events, not data. And we were trying to process data, and it was not working. Nothing was good in there. So we said, okay, now we have an idea. Awesome. Suddenly made sense, but it also meant that we are starting all over again. So our 15 days from the beginning turned into about 8 days, not really that much. So we started something very interesting. We all got together. It was a three-man team, and we started sketching. And we said, okay, we have these events, and we have this many points we have to change, this many transformers, as Eric calls them. And we did the sketch. Okay, it's cool. How do we put them together? Well, we can try and do button clicks like this, and we can call different transformers depending on where we are. And we kind of evolved through this, and we got more complex. I'm sorry, this display is not helping us. But eventually, it started to take shape. And finally, we had a stream. We had something coming in from the top, going through different paths, eventually converging at the bottom, and at the bottom, we'd send a message to the user. And now, for the first time, since we got the project, we had a flow. We built it very, very fast in the 9th day, and it felt for the first time like we could actually pull it off. Now, what we were expecting of this, this is more like how we looked when we started working with how the sprint left. So we thought that we were going towards here. So reduce complexity, most of all. Get some tests in there just to ensure that we're not breaking anything. Being able to add more features to the application, and why not? We want to document it because it looks very nice. And we started working. We had 7 more days, and we had some very interesting benefits. Because I designed it in that flow, each and every component in there was independent. So essentially, all the 3 of us started working, and each of us working on a different component. So we have this event going in, this event going out. I do this processing, I put it into the event, I ship it out. Each of us worked on pieces for 4 days. Nothing was coming together, but each of us were testing the shit out of everything. So this is why I said there it was like testability overload. Complexity shifted, but not decreased. It was actually, I could say, worse than before, because at least in the callback hell, you can follow the pattern and you can see where you are going. When you're going towards RX, tends to decouple and to break apart, and you have these pieces lying everywhere and events being consumed, and if you don't wire them properly, the stream will just go to a point and you have no idea why, and you start debugging, and it's really hard to go through them. So complexity was not really an improvement for us. But I'm pretty sure that, okay, so what I forgot to say here is that we actually did coding all the way up until the demo, and 30 minutes before the demo, we were still fixing stuff. Eventually, much to our surprise, everything was done, so we managed to implement everything in RX. So, yay, great victory. Owner was happy, he had no idea that happened behind him, and we just advertised that, hey, we are now async and we can handle more requests. But I'm pretty sure that you're not here to see how I got through this sprint or how my team got to this sprint. So I have some learned lessons from you. Most of them are not from RX. So first of all is you have to see it before you build it. Now, I know that most of us did computer science and we are taught how to write code. So whatever we want to fix, we fix by writing code. But in our case, this diagram, as it is, actually was the main point why we were able to finish it in 7 days. Because each of us would go to this diagram and say, okay, which is not implemented? That one, I'll pick it. I know the event type, I know what it has to do, I'll go through it. This was a diagram when we started. This is how it looks when we ended. When we didn't end. This is how it looks now. And the product owner liked this diagram very much and said, okay, put this into documentation for business. It doesn't belong in there. Just put it there. It looks very nice. Okay. Next question I get from the next business meeting. I saw this very complex diagram. What is it about? I didn't understand. So that's why I kind of put this square up here. It says this is designed for development and debugging purposes, and it's for developers. Please don't bug us. It's still there, but it looks nice. One item that I summarized as be kind is put stuff in there that's going to help you in 2 days or 1 week or 1 month, or to help others. For example, in this flow, we said, okay, we have requests, and if it's for example button click, do this flow. If it's killing me. Anyway, we're handling simple messages like, hey, welcome back. We are handling notifications for the user, and everything is in this flow. So when a message comes, it could actually go on 1 flow or 2 or 3 flows, and they all sync in the bottom and converge and say, okay, send the message to the customer. Now, one thing that we found out as soon as we connected this to the external services is that we did a lot of error planning, and yet it was not enough. It was barely 1/4 of what we are receiving. Errors from anywhere from to just a pain. So 2 sprints later, we had to do this and harden the application, as in, okay, let's treat everything. Let's see what errors may come. Let's just make it happen. And our conclusion was that it was very easy if we could handle errors just like an event. Hey, we have an error, that's an event. And what happened? Well, we called the store, and we were expecting some data, but didn't come back. So what we said, okay, now let's emit an event that looks just like a store reply, but put a flag for failure and put the body of the exception inside it. So later down the stream, it can be analyzed, and we can say to the user, sorry, try again, and put the real message in the logs. One problem that we had was that our solution was not on Stack Overflow. We really looked for design patterns. We really looked for something that could satisfy our needs, our flexibility, our use cases, and nothing was out there. So essentially, just as you saw, we started building it, and we built it from scratch. And later on, we were even asked, why did we not use this event messaging framework and other tools? Well, first of all, we were not looking for them. We were looking for just simple stuff to solve our solution with branching and callback hell. And the second item is that I am not sure that I would have picked them if I would know that. Because with every framework like this, you inherit some technical debt. Now, we all think of technical debt as being something that was built an application, nobody wants to touch, it's hard to change, and so on. But you can actually get technical debt from all the frameworks that bring stuff that you don't use. And suddenly application is lower, and it's harder to find things, and they may be more generic, and everything, when it's generified, it's harder to narrow down on your use case. So we were very happy with our solution. And last but not least is you have to test it. Now, this looks very green. It has very high coverage, about 95%, and we even have components that are 100% tested. This was in that sprint. We didn't build it afterwards. We built it along with the code. If you want, it's test-driven development, but I don't really like to say it like that. But anyway, whatever you build, put the text right next to the code whenever you want, before or after coding. And I think this is everything that I want to tell you as lessons learned. But just to show you where we are, fast forward today, testing-wise, we have 350 unit tests covering a lot of the code and a couple of integration tests. Really, they just look like the first ones, but now they are more robust, and they use them just to check for entire flows. That makes us very happy because we use those building blocks, and they are very easy to connect with each other. So they consume an event, they emit an event, everything's fine. Is probably just like Victor's presentation so far. That gave us a very evolvable architecture. So whenever the customer comes, we know where to break it apart, where to create a new flow, where to connect it, and it's done. New features come very easy to build in this architecture. Business complexity, well, we did get to put more stuff into the application and it grew, and we maintain the same standard for testing. So we are very able to add more features into this kind of application. Documentation-wise, we build it about 30 markdowns describing processes, images, business decisions, how do we deployment, how we code. It's in there. We have a bunch of diagrams describing everything. The only one that's left is code complexity. That's still high, and we're okay with it because we have tests and documentation. And to give you an image, this is where we started from testability being kind of low, documentability being no, and we got to here. And I actually put there for testability, if you do the sum, it's 5 in total. That's the top number, because honestly, it's just so easy to test. It's really easy. Now, testability and documentation are the things that give us flexibility. And flexibility is what makes us, along with all the others, cope with the complexity that increased here. If I am to take you right now documentation and tests from the code and tell you debug this, you're going to break your neck, because it's very hard to take everything apart and say, okay, now I'll send this event and somebody will pick it up later on. If you forgot to write it correctly, nobody will pick it up and you'll have no idea why. So also, this is how it looks like now. Still 95% coverage. We have one offender here. We'll take care of it. But we still did this on the fly. Write the code, test it. Write the code, test it. And it was very easy for us. Very easy to grow in this context. Now, conclusions, just so I summarize everything. Complexity shifted. You won't get much better with RX than you are with callbacks if you're looking for complexity decrease. You can't. However, if you make it testable and you build documents around it, you can really get a step up from callbacks. So I call this, it's more like promises on steroids when you think about RX. And last but not least, flexibility is given through test and documentability, so it allows you to update to business, because essentially we build our software as a reflection of the world, or of the client's world, if you want. And if the world for the client is changing, we have to change the software. And in this solution, we found a way that we could actually evolve this, and in 3 years' time, still be flexible to add more changes. And my last item for here is that we used to write code for machines, so that's why we were very focused on writing code and typing, and everything was fine. But right now, we are in the age where we have to write code for people, for us and for our colleagues, and to anybody who wants to see the code. That's it from me. Thank you. If you have any questions.
Okay. One question that was addressed: what was the actual business or user problem you were solving?
So we are building a chatbot, and right now this was connecting with Facebook, but we had requirements to connect with multiple services in the future. So the problem was that we were receiving a request from the user and trying to orchestrate with callbacks 3 other services. So calling 3 other services, getting the results in a certain order, aggregating the result and responding. And this was nice on the paper, not so nice when the error started hitting us and when we started to add features. So that was the use case for us.
How do you keep the documentation up to date? Is there a way of generating the diagram from code or at the runtime?
Believe me, I tried. Being the architect in the team, I actually looked for this quite a lot. But in the end, once you build it, it's kind of hard until you design it. It's a bit difficult to get into a shape where it becomes visible and easy to follow. But then it becomes very easy to update. It's easy to add another block. And I don't do updates as in, hey, I'm the architect in the team. I'll go there and I'll just put a block here and the team will go, yes, master. No, I get the team around, we discuss, we see, where do we put this one? I want it to be put here. And the other go, no, it should be put here because it's just a check in here. So it's a team discussion. And when a team gets involved, it's very easy to decide on a flow very fast, put the block right there very fast, export the JPEG, and in half an hour, you're done. You have just added a new feature, first of all, in the design, and then you get to implement it.
What do you recommend for testing RX code, and how can we write RX code that is testable?
Anything works, honestly, because they are just very small blocks. We do it with the JUnit. It's Java, so it's very easy for us. Honestly, I'm a big fan of TestNG, but really they haven't had time to put in there. But anything goes. As long as you're testing these small pieces. One of the pretty fine things that were in this code is that we were able to unit test a collection of transformers. So take a whole chain and see, hey, does it work properly? So essentially, we tested the whole chain with one unit test, and we just mocked the classes that were calling the outside services. So this one, it was clean. It was not doing anything with that required delay or processing or anything like this. It was just clean. And out of those 360 service tests, I think it's about 30 tests that check the whole flow. And for us, it was an improvement. And then integration test is just on top. Okay, just put this into a server and run it. We're already confident it works.
What is the unit under test? A single class or a group of classes to test the entire flow?
I think I just answered this one. The unit can be, so we have unit tests that focus on methods. That's it. We have unit tests that test transformers. We have unit tests that test larger collections of transformers.
Why did you start drawing so late? Maybe that would have gave you an earlier clear view.
We received this project from the outside. It was a proof of concept, and the first month or so, we just started to understand it, to see how it works. And I drew the services that how they were connecting and how they wanted to break it apart and how they will evolve. But I never drew it inside the service. Inside the service was much of a gray area. It was working, so let it be, don't touch it. Eventually, we had to touch it, so we diagrammed that.
Usually there needs to be a fine line between sync and async code. Do you guys have any insights on when it is worth the effort and when it is an overkill?
That's a trick question, because for us, we tried very, very hard to put as much as we can into this set of async blocks. Because if I am to, actually, I'm not going to go back, but the top blocks can be collapsed into only one and say, okay, now we're doing pre-processing, processing with the AI and shipping to the customer. But it was very easy for us to follow testability and say, okay, for testability purposes, let's build these small blocks. Let's build it just like this. And we worked really, really hard to extend this as much as we can and get as much code into this flow. And what we couldn't get into this flow was actually the server setup, and that's about it. So the server calls it's a handler, and this is the handler. That's the only part that we couldn't get into async code.
One more question. How mature is RX Java, and what kind of projects would you recommend for?
How mature? I would say pretty mature. It has quite a big audience, but also many areas I think that are undefined, because you'll usually find documentation on how to build string processing with RX or integer processing with RX. Very, very hard. I could actually find real use cases. Okay, you use RX for this real life scenario. So maybe this one is area that will be covered in the future, but it has a very intense audience behind it. So I'm guessing pretty mature. And what I would recommend it for? Anything that makes you call asynchronous something on the outside. Because you could say, okay, I have done this beautiful machine that works on this software that works on a machine, and it's perfectly synchronous, and it is, I don't know, whatever you want to use. The second you do a call that's asynchronous, it's going to break the machine. And we usually don't think like this, but database calls are asynchronous, obviously, But file reads are asynchronous, and we don't usually like to think of file reads as being something that we have to wait for. But in case of large files, we do have to wait for. Internet calls are always asynchronous, and we had just about everything of all of these. So for us, it was a perfect match. But once you have a number of calls, it depends on you, that are asynchronous, start thinking of using something like this. Callbacks are not going to go very far.
Thank you very much, Cristi.
Thank you.